Well, this session is Write Once, Pwn Everywhere. Your speaker is Yang Yu, and thank you, and I hope you enjoy.
Good morning, everyone. This is my first presentation in Black Hat. To be honest, I'm a little nervous, so I hope Smile can make up for my terrible English and really ugly slides. Thank you. My presentation will be in 4 parts. The first 2 parts are about bypass ASLR, and the other 2 parts are about bypass DEP. Yeah, my name is Yang. I work for Tencent, a Chinese company. Tencent is the company name, not the money they paid me. Nobody works for Tencent, that's too little. Huh? I joined the security industry from 2002. Most of my research is about exploiting and detection. But before 2002, I was working hard for my MD degree, and I finally got it. I almost became a doctor. But now you see, I'm a computer monkey. Like you guys. See the difference? See the difference? No girls anymore. That's our job. Yeah. Okay, let's get down to business. Once upon a time, JavaScript used BSTR to store string object data. The BSTR structure had 2 parts. You see the point? Yeah. 2 parts. The length and the date. When we create a string in the JavaScript, it will generate a BSTR in memory, like this. The length, the date. Yeah. Because of the length, the string object cannot access the data out of bounds. But if we use some vulnerability to increase the length, then we can access any data after the BSTR. Like this. The length, yeah. Then we use some vulnerability to overwrite the length with a really large value. Yeah. And now we can do out-of-bounds reading. That means info leak and bypass ASLR. And the address of the length, we can calculate it out. Yeah. This length, we can calculate this length. First, change any character in the spread string by some vulnerability, and then check each character. Find out which one was changed, and calculate the offset to the initial of the string. Then we get the address. First, spray the traditional heap spree. This is our spread address. And we write to this address. We spread with 0, and we change some character. And we find the character not 0. Yeah. Finally, we can calculate the address. But from IE9, JavaScript 5 was abandoned. JavaScript 9 replaced it. And JavaScript 9 did not use BSTR now. Fortunately, JavaScript 5 is still in the system for the compatibility, like many old things. So we can summon it back, like some old ghost. So we need a magic spell. Yeah. This is our magic spell. JavaScript 9 did not support script encoding. So if you set encode tag, JavaScript 5 will be re-recruited. The compact tag is also work, but some features are not supported, like EVAL function. Yeah. That's our spell. Okay. So it seems that we got everything. Now we can have BSTR again. We can do info leak, then ROP. And the JavaScript 5 is universal. This trick can work from IE6 to IE11, maybe 12. Yeah. But is JavaScript 9 really unexploitable? No. Now let's talk about the JavaScript 9. JavaScript 9 and JavaScript 5 are maybe nearly identical for web developers, but they are very different internally. Even the file size of the JavaScript 9 is much bigger. Yeah. And I always say we should thank Google V8 and those speed tests. Yeah. Because of them, although JavaScript 9 is no longer use BSTR, but there is something new and better. JavaScript 9 is designed to fast. Yeah. So the security is not the highest priority. Let's see about this. This is how JavaScript 9 stores string object data. The length and the date are in different memory address. The length, and the date. Yeah, this is the length, the data address, and the date. You see, they are in different address. And although BSTR is gone, spraying string data is meaningless. But we can spray string object, not string date, but a string object. Yeah. We don't spray some big strings. we spray many small strings. See, just 2 characters. Yeah. We spray a very short string many times, then we get the string object on the address we wanted. Yeah. So do the length. Using this technique, we even do not need to locate the length address. We can control it. See, this length is in the sprayed address. Yeah. The sprayed address. Yeah. Right? So I say it's much better. But if you really like the locating game, we also have something like BSTR. In JavaScript 9, the array data is our new BSTR. See, we create many big arrays. Yeah, we create many big arrays. This is one of the array objects we create. And this is the array date. And we can see there is 3 lengths. There is 3 lengths. 1, 1, 2, 3. Yeah, there is 3 lengths. 1 is in the object, 2 are in the date. See that the red number below, that is the length we will rewrite. This one, yeah. Locating array data length is very similar to locating BSTR length. Just write a sprayed address, then check each number value, find out which one was changed, and calculate the offset to the initial of the array. And then we got it. But the real challenge is here. There is a little difference between BSTR and array date. If only enlarge length in the array data prefix, the outer bounds read will be filled. Yeah, because JavaScript 9 will check that 3 lengths. Yeah. We just say there are 3 lengths. JavaScript 9 will check that 3 lengths while reading array data. You can't just overwrite one of them. If we just overwrite this and do outer bounds reading, it will be filled. Yeah. But, yeah. Although we can't do outer bounds reading, but the outer bounds writing can be done. We can't read, but we can write. It's funny. I don't know why. I don't know why. Yeah. Yeah. And if you do outer bounds writing, the other 2 lengths will be rewrote automatically. I don't know why they they design like this, but just okay. See, we do outer bounds writing, yeah, and these 2 lengths got to be changed automatically. Yeah. Then we can do out-of-bounds reading. Yeah, I think JavaScript 9 is more exploit-friendly. Yeah, we don't need to locating string length. We can control it, and with array, we can write any memory, not only read. BSTR is read only. Now we can read and write. And JavaScript 9 have many other exploit-friendly features. Unfortunately, I don't have enough time to talk all of them. Maybe in other conference. I just show you some interesting objects. Yeah. In JavaScript 9, from IE 10, there are some new objects. These objects make it more easier to read and write memory. Since I don't have enough time to talk all about this, so I left some questions for you. How to turn calling UAF to rewriting UAF? How to trigger a rewriting UAF multiple times without crash? Since BSTR uses system heap, how to bypass the heap gaps in Windows 8? We know the Windows 8 have a new feature. They make gaps in the system heap. Yeah, but only JavaScript 5 face this. The JavaScript 9, like I say, is more exploit-friendly. They use custom heap, no gaps, no gaps. Yeah, and string object is read-only. How to write memory in JavaScript 5? Yeah. And rewriting UAF is not rare, but not every rewriting is exploit-friendly. The first is a lovely one, write any value to any address, but the others are not so lovely, not fully controlled. How to exploit all of them? That's also the question list for you. Yeah. So now we can choose JavaScript 5 or JavaScript 9 to do info leak and the ROP. Yeah, ROP is a great technique, but creating an ROP chain is a laborious process. I'm not a hardworking man. Yeah, they say laziness is the mother of invention. So let's do some invention. Vital point strike. This is Kung Fu Panda. Vital point strike. Vital points are some special points in the human body. A pressure to vital points can make intense pain, even lead to death. Like Achilles heel. Yeah. Many people know about vital points. Chinese people, Japanese people, even Vulcan people. See, Spock really good at this. Vulcan nerve pinch. Who likes Spock? I'm a Spock fan. That is the human body. But is there any vital point in computer memory? Let's think about this. What's the difference between these two programs? The Windows script host and Internet Explorer. In Windows script host or HTML application, JScript can invoke any object, such as WScript shell, yeah, or FSO. It can do almost anything, but IE can't. What's the difference between two programs, these two programs? Yeah, think about that. Yeah. There is a safe mode switch. There is a safe mode switch. This is the Persuade code. That's our vital point. In some special address, as long as even 1 byte be overwritten, your browser will enter guard mode. Guard mode. Then you can do anything: run program, read, write, local file. Yeah, you can do anything. Just 1 byte. Since we can read and write any memories, just like I say in the just like say use the JScript 9 module. Yeah, we can read and write any memories, so we can find this vital point and overwrite it. So we got a guard mode IE. Yeah. But if you really want to do that, there are more puzzles. How to locate the JScript object? How to read JScript object when its address is lower than the corrupt BSTR? And on JScript 9 in IE 11, safe mode is well protected. How to bypass that protect? Yeah, these are all the puzzles. Yeah. And even if you solve all the problems and finally run a program, you still have to deal with this. There will be an alert window. We don't like alert window. Yeah. Yeah. I only have 15 minutes, so I can't present all these techniques. But I really want to talk about the last puzzle. Yeah, this one. That alert window is my favorite. Yeah. It's really tricky. Let's see how to resolve the puzzle. First, we download a library, our Trojan library. Yeah. we use the XML object or the image tag or any other method. The file will be saved in the cache, the cache directory. Since we are already in God mode, we can invoke any object. So we use FSO to search the cache directory to find that library. Yeah. That's the second step. And then we use FSO to create a directory named system32. That's our fake system32. And copy the library to that directory. And named the library as shell32. Yeah. Now we modify the system root environment variable to the upper directory of the fake system32 we just created. The last step is creating shell application object. Yeah, to trigger to loading our fake shell32 library. That's how we load the library with script. Am I clear? Yeah. Simply, we force the IE to think about the system root. The system root directory is our fake directory. So when the IE want to load some library, they just find from our fake directory. Yeah. And the load library is smoothly, no alert window. Yeah. What vital point strike is very universal. It works from old times to modern times. I think it maybe work on Windows 9, 8, and IE5. Yeah. And it even don't need any native shellcode. Just script. This is cool. But there is something more fantastic. Interdimensional execution. Sorry, I really enjoy naming things. Yeah. Since we already can read any memory, so we can create some really cool JavaScript functions like this. Yeah, like this. Even on the ASLR, module address is aligned, so we can find the base address of the module from any pointer, like this. You see that? File A4D. I don't know what's file A4D. That's the data in the PE head. And we use another value in PE head to make it double accurate. with this function, we can make any pointer in memory to become a module base address. Yeah. When we got a module's base address, but this module is not what we want, we can use that function to find out any module in the import table, like a kernel 3.2. Yeah, this function will read a module's import table and find out we needed another module. Yeah. It's quite simple. You just put the first module base address here and put the module name you wanted here. Yeah. And get proc address. Yeah, we can create a JavaScript version get proc address to get any API from any module. All those can be done by just JavaScript. Yeah. We can read the PE data. Certainly, we can do this. Now, by walking through import tables and JavaScript version get proc address, we can get almost any API from any module. Then we can do this in JavaScript, like in C. This code seems really like C, but it's JavaScript. Yeah. This is some pointer. It's an object address. We just pick it, and we got the JavaScript 9. We got this. We got the JavaScript 9 module base address from JavaScript object pointer address. Yeah, and almost any module import kernel 3.2. So we certainly can get module from import. We use get module from import function to get a kernel 3.2 base address from JavaScript 9. And we also get NTDLL from kernel 3.2. Yeah. And the virtual protect, the WinExec. These two APIs are familiar and reasonable. But why NT continue? Why NT continue? Okay. NT continue is a powerful native API for exploit writer. Yeah. It can fully control all the registers, including ESP and EIP. Another good news is the value of the second parameter does not important. You can just set any value, or you just ignore it. we just need to set the first parameter. Yeah, we just need to set this. This is not important. Yeah. The first parameter is a structure include every register and a flags. We can find this in MSDN. This is the flags. And these are the registers. Okay, let's put these together and see what could we do. When we do any object operation in JavaScript, it will trigger at least one native call. And the object itself will be pushed to the stack as the first parameter. The first number of almost all objects are a function pointer table, like this array object. This is our array object. This is a function table. Yeah, this is a function table. When we do some operation, to the array, that will trigger a function pointer call. Yeah. And we can see this address is the object. Yeah. Is in the ESP. Yeah. This is the first parameter. So, we can call any function. By rewriting the function pointer table. Yeah. Since we can write any address, yeah, of course we can change this. So we can call any function by rewriting the function pointer table. And most of the data in the first parameter almost can be controlled. Yeah. I mean this is the first parameter. The first parameter is the object. Every byte we can rewrite it. And we put anti-continue in a fake object function pointer table. This. Yeah. And overwrite the object date to thread context structure. Then we can call any function with any parameters by controlling the EIP and the ESP. Because we use the object itself as a parameter of anti-continue. So the first member in thread context, that is context flags. See this EAX here. It is a function table, and it's also our flags. Yeah, that's one stone, two birds. Yeah. Let's make it more clear. This is the fake thread context. Yeah. Our fake context. Here is the ESP. In this case, we set EIP to the virtual protect and set ESP to a faked stake. In this faked stake frame, the return address is pointed to our shell code. So when NT-continue is executed, virtual protect will reset the shellcode memory attribute and return to execute. And since we already know the shellcode address, and we have JavaScript version get proc address, and those functions, so the native shellcode do not need get PCE or read PEB. We can do this in JavaScript. So this kind of shellcode may be difficult to detect and identify. Yeah. Let's see. This is the meaning of interdimensional. Native dimension and script dimension, they can communicate with each other and work together. We use script to get our API address and set them to native shellcode. Yeah. And most of the native shellcode can write by C, like this. Put all the pointer in a table and use JavaScript to get those pointer. Whatever how big is the shellcode, just need one assembly code to set the EBP to the pointer table created by JavaScript. This is the finally native shellcode, really tiny. Yeah. See this? This is our only assembly code. This is the shellcode. Now put the native code and the JavaScript code together. We got this interdimensional code. The script will get all pointer we needed and give it to the native shellcode, and then use NT-continue to execute it. Interdimensional execution is a little bit like ROP, but totally not. We don't need any fixed things. So it is incredible universal. And it not only can be used in IE, and not only can be used in Windows. That's what I mean. Write once, pawn anywhere. Yeah. I I have write an exploit in Windows 7, and without any modify, it will it work good on Windows 8. Yeah, that's write once, pawn anywhere. I think it is like TARDIS, travel in different dimensions, do really cool things. Vital point strike and interdimensional execution are different from traditional exploit technique. Make sure your APT detection system can handle them. And I always like to use this slide to end my presentation. 2,000 years ago, Confucius said, while you do not know life, how can you know about death? And similarly, while you do not know attack, how can you know about defense? Agent Smith said. Okay, that is all. Any question? Okay. No question? Okay.
What primitives are necessary in order to be able to do the interdimensional execution? What vulnerability, kind of primitives? So arbitrary read and arbitrary write, is there anything else that's necessary?
Just as I say, we need rewriting UAF or other vulnerability which can rewrite some address. Yeah.
Hi, good talk. Thank you. So I have a question. So do you have any ideas of defending against vital point strike and interdimensional execution? Thank you.
Of course. Yeah. Let's see about this. Actually, there is some key in the interdimensional execution, like anti-continue, Did you find the anti-continue parameters we send to anti-continue is really strange. That's unusual. We can check this key point. Yeah. And and the vital point strike. See, we need to use some object which should not be in IE. Yeah, we can detect this. Yeah. Yeah. Okay. Okay. Thank you, guys.